Good evening. Welcome. Before we transition into the main presentation, we do have some folks attending online. So I just want to give a quick blurb for them so they have an idea of how to handle the meeting. I would ask, so everyone here at this meeting, we've asked to sign in, which you've been wonderful about, so thank you. But since you're online, if you don't mind, please put your name, your agency, or your address, or however you're kind of related to the project, and an email address that we can contact you afterwards if needed into the chat box. Know that if you're online, you're going to be muted and unable to speak. We do have the chat box being monitored, so feel free to ask questions at any time. And just so you folks know too, we're planning on, as we transition from person to person, we're planning on stopping for questions. So you're welcome to hold questions to the end, or you're welcome to ask us questions as we move through the presentation. In the chat, there should be posted somewhere the meeting handout, which was back at the desk. If you signed in and did not get one, because I think I only made 25 copies, if you put an asterisk or something on your way out by your name, I'll make sure to send you one. That way you at least have that as well. And you probably would have seen it already that the meeting is going to be recorded. So if you do not choose to participate in being recorded, now would be the time to exit the meeting. Quietly, we won't judge. Yeah, sorry, I'm gonna see. I know you guys really want to see the front of me. Is there a way to, can you help me with that? All right. So we are here to talk about the Martins Creek Watershed Project that we've been working on. Welcome, and to start some introductions.
For those of you who don't know, I'm Charlie Litwin, Mayor Nicholson. I just want to welcome everybody. Thank you all for coming out tonight. Want to introduce some folks, some local dignitaries that are here. We appreciate you coming out and support. We have Bernie King, County Commissioner, Tom Henry, County Commissioner, Neil Tagg from the Wyoming County Conservation District. From the Nicholson Council, we have President John Kerloop, we have John Decker, John Bauer, Joan Jenkins, Nate Hartzer, who also works at the Susquehanna County Conservation District and is a large part of this project, and Jess Bauer. Scott Ellsberg is also here, the Susquehanna County EMA Director, and Ted Roberts, Chief of the Nicholson Fire Department. Looks like just about everybody here has been involved, lived in and around Nicholson their entire life, and since this project has started, I know I thought I was a creek expert and knew how to fix everything, and let me tell you, these folks are totally wrong. These guys are the best of the best, and when it comes to, you'll be very surprised on how everything that we thought would solve everything doesn't necessarily have that much of an impact over time with their modeling and their diagrams and everything, and the hard work that they've done. They're beyond knowledgeable, and I have full and 100% trust in everything they've done. And I'd like to thank them all for everything they do. And I'll turn everything over now to Bernie Scalzo from the Wyoming County Conservation District.
Just thank everyone for coming out. I know it's been a long process, so I appreciate everyone's patience with everything, but we wanted to make sure that you had a very good long-term solution to the problem. So I know it's been a couple of years, and I just appreciate everyone hanging in there with us. I think very soon we'll have a good project at the end.
Nathan, did you want to say anything from Susquehanna County?
Happy to be able to serve on it. You know, to what extent I could as part of the Susquehanna County Conservation.
For those of you that don't know me, my name is Heather Smeltz. I am with the Natural Resources Conservation Service, which is part of the United States Department of Ag. I've been the project lead for this project since it began several years ago. And we'll talk about a little bit of the way through how the project progressed and where we're at. But I do thank you for your patience with us. I know you guys are living with the flooding day in, day out, and we're kind of a step removed. But we're excited to show you what we've come up with and get your opinions and your thoughts on this part of the project. I'd also like to quickly recognize some of my colleagues. Scott Beeman is our structural engineer out of the Montrose office. Aim was supposed to be here and he had his own flooding issues with his washing machine. And did Weston come in? I didn't see Weston, okay. And Weston Kulowski is our local district conservationist here in, well, in the Tunkhannock office, but in the Wyoming County NRCS. So with that, I'd also like to then turn it over to Mike Ward. Mike, do you like, you guys, or would you like me to keep going?
Go ahead, you're doing great.
All right, so, there are 3 of us with NRCS in Pennsylvania that work on these types of projects. And we unfortunately do not have all the expertise we need to be strong in geotech, to be strong in watershed planning, to be strong in hydrology and stream movement and things like that. So what we did was we went out and hired DDK Engineering to be our techs and feet and provide that know-how. So representing DDK here today is Mike Ward. He is the project manager and lead engineer on the project. We also have Andy Hope, who is also an engineer and helping with our watershed planning side. And then who you can't see, but who's managing the Teams chat and everything for, I'm sorry, the Zoom chat and everything for us remotely is Chris Sargent, who provides a lot of the environmental planning support. So that's who you got. Let's talk about why we're here. So were any of you at the first a lot of you first public meeting in 2021? Yep. And so through the planning process, it's a very deliberate process where we are required to have public meetings to keep the public informed, to make sure you know what's going on, as well as to take public input. So this is the second of those 2 required public meetings that we're having. And what we're going to do is talk about the progress and the alternatives that we've talked about and developed so far from our side, and then get your input on that, because the decision has not been made as to what we're doing. We have a recommendation, but ultimately the sponsors of the project, these guys over here and their teams, are the ones that make the decision as to what gets done and what gets moved forward. So your role here tonight is very instrumental. Why are we here? You heard me talk about this in 2021. In 1954, Congress authorized the Secretary of Agriculture to work with local units of government through the Watershed and Flood Prevention Act to address flooding issues or address land treatment issues in different watersheds. It's often called the Small Watershed Program because we can only work in watersheds less than 390 square miles, which is about 250,000 acres. Martins Creek watershed, and in 1961, a watershed work plan was done that authorized the construction of the Kingsley and Brooklyn Dam, which you'll see on the next slide. And the main purpose of that was flood reduction. And if you notice our sponsors, they were at that time, it was Susquehanna County Commissioners and the Soil Conservation District. So at that point, all the work was planned in Susquehanna County. And it was led by the Committee of Flood Control for Brooklyn and Kingsley. And you can see some of those, the major storm events. So the dams were constructed and are doing their jobs well for those communities. And the flooding in those communities was reduced. However, it didn't quite go far enough and nothing ever made it down. Those dams are too high up in the watershed to significantly control flooding down here in the Nicholson area. So at that point, the Wyoming County Conservation District and the Nicholson Borough reached back out to NRCS and said, hey, you guys did good work up there, but what about us down here? Can you do anything and help us with our flooding now down in this area? So we embarked in the watershed planning process. Planning is the first phase of a 3-part process to actually build something. Because these types of projects are expensive, multi-million-dollar projects, and they're using taxpayer dollars, they need to be very deliberately planned and make sure that they're a good use of those taxpayer dollars. I know you can joke now about federal government and taxpayer dollars, but we do our best from our side of it to make sure that we are using taxpayer dollars efficiently. So it's a three-part process. The planning phase that we're in now, which can take generally 2 to 3 years. The design phase, which includes permitting, and then construction. Now, if you were here last time, you'll remember my crock pot. This is an extended process, but I always joke, I don't joke, I'm very serious, that better things come out of a crock pot than they do a microwave. So instead of just quickly reacting to things and looking at what can be done, we are taking a long, deliberate, slow process to make sure that we are spending taxpayer dollars efficiently. So relating to that plan, we're quickly going to talk with you tonight about what we've done, like problems and opportunities, determine the objectives, and inventory the resources, analyze the data, develop alternatives, evaluate those alternatives, and then you are part of the step that we're at here, making the decision before we move forward and ask for funding to implement the plan. So with that, are there any questions in anything I've covered so far? And I'm going to turn it over to Andy to keep going.
Great. Thank you, and good evening, folks. Nice to be here. So I'm going to step you through just some of the work that has already been completed as part of the watershed planning process. Obviously, we start off this entire process by identifying the problems and trying to come up with opportunities to resolve those problems. There are really two main divisions here. We have our economic impacts to structures and infrastructure within the town. We're looking for ways to minimize flooding and protect those resources. We want to make sure that we're protecting all of your personal belongings and just making life a little bit easier by not having to deal with these flooding conditions on a continued basis. So we have the economic side, and then we have the environmental or ecological side, where we're dealing with the impacts from flooding due to stream bank erosion, increased sedimentation within the stream, just decreased water quality in general. So those are the problems, and of course, with every problem, there are potential opportunities to make improvements. And of course, the most important thing here is human health and safety. So when we talk about flood mitigation, we want to make sure that we're reducing the risk to life. We're protecting the resources that you have in town, but also looking for opportunities to improve on the conditions that are here already. Again, looking for ways to improve water quality, stabilizing stream banks that may be eroding, and just an overall improvement in quality of life. So part of the process is coming up with a purpose and need for the project. And that's part of determining the objectives for the project. Here, we know that there is rather frequent flooding within the town. And that means that we are looking at establishing a threshold to limit flooding as frequent as a 2-inch rainfall event, which is more or less the annual storm event. 2 inches is about the maximum precipitation that you would realize in any one year. Of course, we do understand that we want to maintain access to the stream for fishing, recreational purposes. So we need to come up with strategies that meet both of those objectives, protecting properties, but still maintaining access to the stream. So the DDK team, along with NRCS, has been busy completing all sorts of work over the last couple of years. There's been a variety of field investigations and work performed at our offices, just doing desktop reviews and reviewing available information. Probably the more important ones include the topographic survey. Recently, we came down and performed a wetland delineation, established ordinary high water, We've looked at various databases for historical resources, both archaeological and historic structures. We're looking at potential impacts to climate change and rare and threatened endangered species. So we're really taking a comprehensive look at all the resources that are around town. This slide here just gives you a few examples of what we're looking at when we're performing a desktop review. We're looking at historical maps over on the left, reviewing existing soil mapping, determining hydrologic soil groups, basically the overall characteristics of within the watershed. So the H&H analysis, hydrologic and hydraulic analysis, the meat of the project, and Mike's going to go into a lot more detail on that. But this is really where we come to have a greater understanding of what's happening in the watershed. And that involves first determining the actual volume of water that's coming through the watershed. And that's done by looking at the topography of the watershed, the land cover, the soil types. All of that has a determination on how much water actually arrives in. And then once we establish those values, then they can be plugged into our computer model, and we can evaluate hydraulic conditions, which tells us more about what is the extent of the inundation and how fast is the water moving. And that all informs us on what appropriate strategies can be taken to mitigate flooding. So once we understand the issues, once we've studied the watershed, then we can start to formulate ideas. And again, this kind of goes back to the main purpose and need. What do we really want to accomplish here? Well, we want to reduce flood damages. That's really why we're here. And there are multiple different thresholds of that based on the storm event that we're trying to design to. But in this case, we're looking to control for the 2-inch storm event while also maintaining all of our land uses and access to the stream. Mike will be going into a few more of these flood protection strategies, but there are several. Flood volume and rate reduction is sort of what Heather was talking about at the beginning. We have existing upstream flood control structures in place that are very effective at reducing the volume of water that arrives in the stream. That's just one strategy. Avoidance, we're talking about potential relocations of structures or buyouts. With floodproofing options, we're considering either a wet floodproofing or dry floodproofing strategy where we can implement barriers on the existing structure or improve the openings that exist on structures so that floodwaters can easily come in and exit once the flood event is concluded. We can talk about barriers as a potential strategy. The use of flood walls is one that's being considered here. And finally, drainage improvements, things like improving the stream channel, potential diversion structure where you're taking a portion of the flows and redirecting it down the stream. So those are kind of like the basics on different flood protection strategies. Like I said, Mike's going to go into a little more detail, but any questions about what I hit on there?
Thanks, Andy. Hi, everyone. Okay, so Andy kind of went over the general idea of these 5 strategies. So I'm going to describe maybe some more specifics of how we looked at each of those strategies for this project. And we want to talk more about what we think will work and less about what won't, but I'll give you a little rundown of at least what we went through uh, in evaluating these alternatives. So for the flood volume and rate reduction, as Andy said, we're trying to establish structures upstream to keep the floodwaters from making it to Nicholson in the first place. So some of the more specific things that we looked at for this project is we said, what if we can do upstream land use changes or infiltration areas? And those are nice projects because they're typically green, so to speak. They involve, establishing forested areas, landscaping elements and things to help capture the runoff. For this project, through our evaluations, we found that they're not a great alternative, just given the watershed of Martins Creek and Nicholson is about 52 square miles. And while these types of projects are nice little projects at the scale of this watershed, they aren't real effective. And also combined with a lot of Martins Creek is pretty rural, as you know, so a lot of it is already forested. There's a lot of green space in the watershed as it is. So there's not a lot of opportunity to make a big change in that regard. The next two bullets we have there are looking at upstream detention ponds. The other strategy is, can we establish a structure upstream that will capture rainfall and then release it in a controlled rate so it's not coming so fast and so hard at one time in Nicholson here. And then a specific one that we thought we'd mention with those ponds is the Alford Pond. We looked at, can we rehabilitate the Alford Pond and maybe better utilize it to storm runoff, as well as improving the stability of that pond. So the next slide here, I can talk a bit more. Hopefully you can see this okay. I don't think you need to see the details, but the blue boundary here is the limit of Martins Creek watershed. We are down here at the bottom in Nicholson. And these kind of teal circles here are existing ponds that we evaluated preliminarily to see, could we just modify an existing pond rather than starting from scratch? Can we just upgrade one that's already there? And so we had a few Lake Kristen, Beaver Meadow Pond, Pratt Road Pond, and Jones Lake Pond. We preliminarily screened those. One of the challenges with existing ponds is oftentimes they'll have a community around them. So there's existing residences and things. So the challenge with modifying existing pond is for it to store more rainfall, which is what we would want. We would either have to permanently lower the pool, and in that case, the residences around there no longer have access to the water. So it's not a great alternative. The other option is raise a dam or construct another structure around it and allow the pool to come up during a storm. But obviously, in that event, we would flood the residences around it. So there's a lot of challenges with modifying an existing pond. So then we moved on to, what if we just build a new pond in the upstream watershed somewhere? And so those are the blue circles here. There's a few of them. And we looked at a handful upstream in Susquehanna County, including the Alford Pond, 2 different sites in Brooklyn, 1 site in Kingsley, and 1 site in Hot Bottom. And then we looked at a few potential locations closer to home here in Wyoming County. One just upstream at the housing authority, near the housing authority structure. One near the former Mill Pond site, just upstream, and then one just a little further up near the NEG Building Products property. And so just to give you an idea, this is, I'm not sure how well you can see this, but this is a little screenshot of the lower Alford Pond. And just to give you a feel for how we evaluated them, we established topographic contours of the pond to get a stage storage area or stage storage relationship, so that we could evaluate how much water could this potentially store. We did some preliminary grading shown here to have an idea of what type of a dam or embankment could we fit in there. with any of these, we dealt with certain site constraints, you know, existing roads, existing residences, utility lines. We need to think about if we establish a new pond, what would be directly impacted by the earthwork and things to establish it, but also when it rains, it's going to flood things upstream by temporarily holding that water. So we worked within those site constraints to preliminarily evaluate these ponds. And then with that, kind of as Heather touched on earlier, we also have to consider where are these in the watershed? If we're too far upstream, then we're not controlling enough watershed to really make a difference. It's a 52 square mile watershed, so we need to control a lot of it to make a difference all the way at the bottom here. And then, as I said, the storage volume is also critical. It's just a large volume of water, so we need to store a lot to make a big difference. Going through that process, as I said, a lot of the existing ponds don't look great just because of the impacts for everything around them. We did some detailed hydrologic and hydraulic modeling for the sites in Brooklyn, Kingsley, and Hot Bottom. And the general story with those is from the modeling, we were able to determine that they're not real effective at reducing flooding all the way down here. They do provide some benefit, but we're limited with size with the existing roadways and structures around them. One of the best projects that we had was probably rehabilitating Alfred Pond. So that's the one that I have shown here. And we'll touch more on that later in the presentation, but that was kind of the procedure that we went through for this first category. The second and third categories, avoidance and floodproofing. From an engineering perspective, we kind of evaluate those in the same manner. As Andy said, avoidance, we're looking at potential buyouts. So if there's a structure that's just really flood prone, from an economic perspective, it might make sense to purchase that property at a fair market value, make arrangements for that person to move to a similar residence or property, and then convert the former property to a green space. So that's very effective in terms of preventing flood damages, but we also recognize how sensitive that can be to a community to want to move people out. So we do evaluate that in the process. We'll touch more on it a little bit later. We also looked at relocating structures and raising structures. So relocating structures, the limitation in a town like Nicholson is if you want to move a structure, you have to have a place to move it to. And down in Nicholson here, a lot of the flood prone areas, there's not an obvious place to move them to without bumping into some other structures. So the relocation isn't a great alternative. Raising structures is another one. So in that case, you would actually modify the foundations of the structure, jack it up, and rebuild a foundation under it. So the living space and everything is now higher than the anticipated flooding level. One of the challenges with that, we understand that a lot of structures in Nicholson are fairly old. The older a structure is, the more challenges there are to modify the foundation and move it without damaging it. And the other thing to consider if you elevate a structure is access. So there are some structures in Nicholson that we estimate for larger storms to be inundated by several feet, 5, 6 feet deep. So you can imagine if we can physically lift that structure up that distance, but then to access the living space and things, we have to establish stairs or ramps. So, you know, again, we didn't see that as a great option, at least on a broad basis for a lot of the structures in town here. And then Andy had mentioned floodproofing. So there's dry floodproofing and wet floodproofing. For dry floodproofing, it's better suited to more shallow flooding, 3 feet or less. And that's mainly because of the structural capacity of typical residential construction. you know, water exhibits a lot of hydrostatic pressure on walls and things. So you could make it watertight, but you'd be worried about the structural capacity of the walls above a few feet. And unfortunately, for some of the more severe cases in Nicholson, the flooding exceeds a few feet. So dry flood proofing, again, on a broad basis, isn't a great fit. Wet flood proofing, as Andy mentioned, you're going to modify the structures to either use waterproof construction materials or allow flooding to come into the structure and then it could be safely pumped out later. You're going to move your critical features of your house, your electric panel, your hot water heater, things like that, to higher levels to protect them. So that is an option, although one of the big drawbacks is you still have to allow flooding to come into your house for wet flood proofing. So oftentimes wet flood proofing is associated with abandoning the lower levels of your home. It works great if you have a structure where maybe you just park cars in the lower portion of a garage. So you might not have much in there. It's not really a living space. And you just temporarily park cars. So during a flood, you could allow that to fill up. You just move your cars and then it can drain out or be pumped out later. But, you know, based on a lot of the homes in Nicholson, I believe there's some confined basements and things. People want that living space. So wet flood proofing, again, on a broad basis is probably not a great fit. These types of things sometimes could be used for isolated structures here and there if it fits well, but on a broad basis, probably not a great alternative. And this is just a look at sort of how we evaluate the avoidance and the flood proofing. So this map here, Martins Creek is shown in this dark blue line. And the inundation area, or where we expect it to flood, is shown in kind of this teal shaded area. And in general, the darker the color, the deeper the flooding. So you can see at the edges here, it kind of fades out to nearly nothing, but it's, you know, a darker color next to the creek, as you would expect. And so we developed this inundation area based on our detailed modeling. And we have the structures, at least most of the structures are outlined in the red barriers here that you can probably recognize. I think this is Nicholson Tire here for a point of reference. But so to look at the avoidance and flood proofing, we developed this detailed model and we can tell you the approximate flooding depth at each structure. And then think about what might make sense to modify it. But so you could see the challenge if we wanted to do relocations. There are a lot of structures near the creek here and maybe not a lot of places to move them.
Like, what storm is that?
This is the 100-year storm, sorry. So this is a pretty extreme storm event, the 100-year storm. And I should mention that for this project, we evaluated a variety of storms, as small as the 2-year storm, all the way up to the 500-year storm. So we evaluate that range. We can see the extreme ends of both, and then as we'll talk about later, we kind of compare the economic benefit and cost for controlling those different storms. And these are additional maps similar as what we were just looking at. The 10-year storm is on the left, the 25-year storm is on the right. So you can notice, as you would expect, the flooding limit for the 10-year storm is less than that of the 25-year, which is less than the 100-year. But you can see even for the 10-year storm, we have a handful of structures in the expected flooding area. And I'm sure some of you may live at these structures and might recognize that. But so that's kind of how we evaluated buyouts and relocations. Drainage improvements. From an engineering perspective, drainage improvements are kind of fun because you can use your imagination. But as Andy said, we're trying to find ways to divert water around flood sensitive areas or try to improve the capacity of existing structures to get more flood water through and limit flooding of adjacent structures. So for this project, we looked at establishing a diversion culvert or channel through the former trolley corridor. And I'll show a map in a second to kind of talk a little more about these. There was some input during the first public meeting about the pier at the State Street Bridge potentially causing or contributing to flooding. So we looked at eliminating that. We looked at widening Martins Creek through the Nicholson area here, deepening or dredging Martins Creek to improve the flow capacity, and then straightening Martins Creek. Kind of at the southern end of town, we have this nearly 90-degree bend. So we said, what if we could straighten that out and maybe reduce the energy losses there? So with the diversion structure, we have it shown in these pink lines here. We thought that might be a decent alignment. We understand that's along the alignment of a former trolley corridor. So that was a nice corridor where we could avoid a lot of impacts. You know, if this were go to a final design, there may be some impacts to local residents, but it was relatively clear. But we were looking at establishing a large culvert or a large channel that would collect a portion of the flow at Martins Creek up here and divert it around town and then discharge it downstream here. And we had high hopes for that one. What we found through our analysis is that it would help to reduce some flooding in Nicholson, but you could imagine a project of that size starts to become cost prohibitive. That structure would need to be comparable to Martins Creek to make a difference for the types of storms that we're evaluating. So in this case, the cost outweighed the benefit. We also looked at widening the creek. So kind of on the cross section here, we show these green lines. We looked at widening out the creek along the western edge here and thought if we could add a little flow capacity to the creek, then we can pass more of the floodwaters through and limit the flooding to the outside areas. So with this project, the widening, it did help somewhat at reducing flooding, but not to the extent that we had hoped. So in a similar idea, we looked at potentially dredging or deepening the creek, which is shown in this light blue line here. And that one is pretty effective. You can see that the cross section of the creek would be increased quite a bit. So from a hydraulic perspective, that one does pretty well at increasing the capacity of the creek and reducing flooding. One of the challenges with dredging is one, it's very expensive. Once you excavate the material out of the creek, you have to dispose of it somewhere. And with a dredge material like that, it's saturated, so you have to have a disposal site established to dry that out and properly dispose of the material. So you might use technologies like geotubes or a settling pond. But the point is it does kind of get, it's pretty expensive to accomplish. Yeah. And the other challenge with dredging is that it's temporary, as Heather said. So if you dredge it this year, you need to be thinking about in 10, 15, 20 years, you're going to have to do that again and again and again. So when we're looking for a permanent solution, dredging has some disadvantages. And then, and then I also mentioned straightening out the channel here. While that does help to a small degree, it helps to reduce some of the energy losses and improve the flow through this area. Again, for the size of the watershed and the volume of water that we're talking about, it doesn't help significantly. So that's kind of a quick summary of the drainage improvements that we considered. And then we get to barriers. And so barriers are typically flood walls or levees. In this case, they would be established along the banks of Martins Creek through Nicholson. Mostly it would be flood walls just because those take up a smaller footprint. We'll show some typical levees later in the presentation. It would be mostly flood walls. They're typically concrete or masonry structures. And we found those to be pretty effective. We're going to talk more about those. As I said, I wanted to give you a brief rundown of what we looked at, what didn't work. We want to talk more about what we think will work. So flood walls will be more in the discussion as we get further along. And just to kind of help you visualize it, here's a typical detail of a flood wall. So this configuration can vary based on your site conditions, but typically you have some type of a foundation and a vertical component here constructed of cast in place concrete. And then there's usually some type of a facing or an architectural element to make it look, like a nicer landscaping feature. And so how they would work during a storm is they would keep the creek would be on the right side, in this case, the green shaded area. So the flow in the creek would be conveyed along the creek, and it would preserve the other side of it in a dry state. So here's a look at what flood walls might look like for the 100-year storm. So that's a pretty extreme case. And what we have on the left here, the purple shaded area that'll kind of follow with my laser pointer there. That is the extent of flooding if we did nothing. So that's as it stands today. If the 100-year storm were to occur over the watershed, it would flood roughly this purple area. And for a point of reference, the 100-year storm is 5.8 inches of rainfall in 24 hours. If we were to implement flood walls along these orange lines shown, one on each side of the creek, the flooding would be reduced to this blue shaded area. So you can see it would do well to confine the flooding to the footprint of Martins Creek. Now, the drawback for this 100-year option is, again, it's a pretty extreme storm event. The height of the flood walls would vary from 2 feet up to 12 feet, which we realize is, pretty imposing. So probably not preferred. And the other disadvantage is at the State Street Bridge, for this case, to confine the flooding, the bridge would likely be overtopped. So the flood walls would need to extend across State Street, at least temporarily, to control the flooding like we would want. And you can kind of see in the cross section here, the orange elements would be the flood walls, and you can kind of see the creek outlined here in this cross section. You feel what it may look like. So we kind of thought, the extent of those walls is not great. So can we do a little better? Like I mentioned, we're evaluating a range of storm events. So we looked at the 25-year storm. Point of reference, that's 4.4 inches of rainfall in 24 hours, acting over the entire watershed. And so similarly to the last map, the purple zone here is the flooding if we do nothing. If we were to implement flood walls at roughly the orange lines shown here, the flooding is contained to this blue area. Now, for the 25-year storm, the walls would range from 1 to 7 feet, roughly, 8 feet in 1 or 2 isolated areas. So these we thought were getting more practical, right? For a lot of people, we think. We'd be interested to hear input. Sure.
So these walls, is that from the creek bed up
Or is that a wall on the side? Like level with the road, and then it goes up?
Yeah, these would be situated kind of, along the top of the bank here.
Okay,
So the height that we're referencing is from the ground surface at the bank to the top of the wall. So, you know, if you're looking,
so there might be a 7-foot wall somewhere
yes,
that you can't see over into the creek.
right. Yeah, and I think, we kind of run into that, down in this area. I actually have the model here with me, so if we want to look at a particular spot along the creek, we could talk about that. But yes, in general, a lot of the wall heights are more manageable, but there are certainly parts that you wouldn't be able to see over. So we thought we'd look at the 10-year storm. Again, we're trying to find a happy medium where we're providing a good amount of flood protection, but these walls aren't so imposing that they would negatively affect the aesthetics of the town. So a 10-year storm has 3.7 inches of rainfall in 24 hours. And we found for this configuration, the wall heights would range from 1 to 5 feet, with a few isolated areas of 7 feet. So we thought we're getting better there. And you can see again, the purple here is the 10-year storm if we do nothing, and the blue is with the flood walls in place. And I should mention with all of these, we talked about one of the goals for the project is to preserve stream access. So if a flood wall project were to carry forward, we would try to incorporate access points at a few critical spots. So you could still get up and over the wall to access the creek for fishing or, you know, for recreational uses. And then another thing we thought about is where we can, we could use a levee, if that would be more preferred. Levees, I mentioned, they take a larger footprint. So a flood wall might be, you know, 12 to 15 inches wide and then have some drainage features next to it. A levee, it would vary based on the height, but think 15, 20, 30 feet wide by the time you build it out and kind of come up to the crest. Levees are nice though, because they can be stabilized with grass. If you prefer more of a green look, and the side slopes would be such that you could easily walk up and over it. So we'll show some more details for the flood walls later, but that's kind of the overall idea. Okay, any questions on that before I give it back over to Heather? Yeah.
With these flood walls, you're essentially creating exclusion. And you're increasing the pressure of the water into the Tunkhannock.
Well, the Tunkhannock has a much larger watershed, so it does convey the water in a quicker fashion than what it would be without the flood walls. But I think with the size of the Tunkhannock Creek watershed, it would be pretty negligible for what Martins Creek contributes.
You haven't been here for a flood, have you?
Well, I'd be curious to hear your input though.
But one of the things we did study as part of it was there is significant backwater effects from the Tunkhannock coming up into the town. So,
That's part of my concern. You know, everybody, we're talking about Martins Creek, but we need to talk about both at the same time. This isn't gonna solve much of anything because it's just gonna back up out of the Tunkhannock Creek. It's just gonna flood a different area.
I think, go ahead.
No, I was gonna say, we did consider the backwater in the Tunkhannock in our analyses. I'm always interested to hear first-person accounts of what's happening out there. But we did make attempts to look at typical flooding in the Tunkhannock and account for that backwater during these analyses. I mean, you can see, you know, there's the flooding in the Tunkhannock does make it up into here. So even though the backwater is here, it will be contained within the flood walls. That's why the flood walls extend and they're relatively high down in here. Relatively tall, I should say. That makes sense.
I'll throw up, in the last flooding event we just had here in town. It was what, quarter inch from going over to Walden. Yeah. The last time the town flooded, the ballpark only took on about, I'm just using that as reference because we're all familiar with how that flooded. The ballpark probably only took on about 1.5 feet, 2 foot of water. It didn't come up over into the baseball field. This last flooding event that we just had, there's 5 feet of water in the baseball field, in through the stand. So every flooding event that we have in town is different on its own and how it goes into the Tunkhannock watershed. So there's not one, magic.
It's raining. Raining up Martin Street, it comes down Martin Street. It's raining up from Cannon Creek, it comes down.
All different.
Well, that's my only question is like, further down, there isn't much more of Martins Creek after the curve. Anything gonna be done down there? Because that's where I lost like 20 feet of land. Because there's no levee anymore, it's all wiped out. And it keeps coming over and now I have landlocked piece, or piece of landlocked land on the other side of the creek that I can't get to.
Well, I know for this project, our scope was limited to just Martins
town.
Creek. Yeah, I mean, we
And I
did,
understand, that's vital.
yeah. So we tried to account for the confluence with the Tunkhannock in our analyses, but our focus was on Martins Creek and Nicholson.
Mike, we do have a question
Yeah.
online.
Yep, that's a great point. Yeah, I was gonna say, we'll show some details a little later of what we had in mind, but that's exactly right. They keep the water in the creek, but they would also hold water on the upslope side. So typically what you do for that is you might have more passive outlet pipes and things to let the water drain during a smaller storm event. You would install flap gates on those pipes, so they're one-way drainage structures. During a large storm event, we would have to establish sump pumps and collection areas to pump the water that accumulates on the upslope side of the flood walls and put it on the creek side. But we'll have some sketches later to talk more about that. Yep.
Hey, Mike,
Yes, Chris.
we have an online question. Josh Stoll asked, he said it may have been already mentioned, but he wondered whether NRCS would cover the buyout of property, moving of property, or raising of property, or would funds have to be secured from another source?
So that's a great question. Voluntary buyouts, NRCS would cover most of those costs. If it is a mandatory buyout, like it's needed for construction of the flood wall or for something else, it's a sponsor cost. So basically the sponsors, which would be Nicholson and the County Conservation District, are responsible for providing the land for whatever's going to be done. And then NRCS would come in and provide the funding for construction on that land. So that's for if it's mandatory. If it's a voluntary buyout, if we go back to that 100-year storm or something like that, or even pretend we're gonna do a buyout in the area, and it would be voluntary, and you could say, yes, I want to sell my property. I'll take fair market value and go. NRCS would pay most of those costs. There would be some that the local sponsors would have to pay. Does that answer Josh's question?
Yeah, I believe so. Yes, he says.
that, I'm gonna hand it back over to Heather to talk about, how we evaluated all these alternatives. So I kind of gave you a lot of our initial thoughts with our process. But when we went through this, we, tabulated all the alternatives and then compared them to sort of rank them and see what was best. So Heather's gonna go over that.
Thank you. So when we start thinking about how you rank these projects or these potential alternatives against each other, the first thing is, will it be effective? Will it work? Will it reduce the flooding? The second thing was, will the benefits outweigh the costs of it? Because if the costs don't and there aren't offsetting benefits to it, it's not a good use of taxpayer dollars. And then we thought about the social side of it. How's it going to work for public safety? How's it going to work for the tax base that's here in Nicholson? What about community impacts and cultural resources? And then we hit the environmental. Are we going to be dealing with pollutants or adding pollutants? Are we changing land uses significantly that could be of a concern? Are there threatened and endangered species to worry about? So what we did was we put everything on a big table. And the first thing that we did, so you can see all of our different alternatives, the upstream detention, deepening, buyouts, things along those lines. And if you'll notice, the ones that are bolded were the ones that were the alternatives that had preliminary sponsor support. So those are the ones that when we presented everything, Nicholson Borough and the Conservation District said, yes, keep moving forward and keep working with those and don't worry too much about the ones that don't have a flood reduction benefit, or that don't have a significant benefit that outweigh the cost. Now, some of these we had to get into a little bit to figure out what's it going to cost to build and what's the average flood benefit if those properties aren't getting flooded anymore. So that's where the benefit and the cost kind of come out. And as you can see, there's some that definitely had expensive, those are the no's, than the amount of protection that they were going to provide. And then you'll also see some had social and environmental effects. And some of the yeses aren't necessarily bad, or some of the no's aren't necessarily bad. It's just more documenting those effects. So from there, what we did was we pulled out the ones that seemed to be, that had yeses most of the way across. And we got into it a little bit deeper, a little bit better. And then we dug into things. So they definitely, Alfred Pond Rehab, buyouts and the flood walls had strong flood reduction benefits, or at least notable flood reduction benefits. They also, the cost of them was cheaper than the benefit, cheaper than the benefit. I'm saying that right, yes. The benefits outweighed the costs. But as we dug into them a little bit more, things fell out that they may not have had that sponsor support. For the Alfred Pond, I need to point out that, do you remember when I said about the buyouts, that the sponsor is required to provide the land rights to be able to do the work? Not the buyouts for like the flood wall and things like that. I just, that the sponsor needs to provide those land rights, and then NRCS can come in and build whatever we're going to build. It's not in Nicholson Borough, and it's not in Wyoming County. So there wasn't, so even though there's local support here, we didn't have the support in Susquehanna County to move forward with work, with doing anything at Alfred Pond. The buyouts, there was just no good place in Nicholson to be able to keep the tax basis and keep that community support if we bought out the folks in the floodplains. So for those reasons, the buyouts didn't have, once we got further into the numbers and further into looking at things, didn't have the local support here. So that's where we ended up taking a stronger, heavier look at those flood walls. And what we did, and you saw some of this already, but we were looked at each of the different storm events and that's 3.7 inches. That's my bad. That I didn't get the other little one there. Remember that when we were having an opening meeting, one of the things that I clearly heard was that the definition of success for this project is that you didn't have to worry about evacuating people for a 2-year storm event. So that was the bar that we were working with. So for a 10-year storm, got 3.7 inches, a 25-year storm, 4.4 inches in a 24-hour period, and a 100-year storm, the 5.8. This is the average. This is just a summary of what we were. All three of them have permanent stream impacts. All of them, while mostly being on top of bank, we're jutting out into the creek a little bit to protect some of the structures that we didn't have to do buyouts. There's a couple structures, couple homes and businesses that we wanted to avoid and didn't want to have to worry about buying out. So we will be working in the creek for some of those. The 25-year storm and the 100-year storm are definitely may affect or going to affect the State Street Bridge operation. And that could be even shutting it down during those storm events. I didn't quite seem, it could be done, but it was just something to keep in the back of our heads. So I'm going to turn it back over to Mike, unless there's any questions with how we evaluate those alternatives. Should I go back here?
Yeah, you're mentioning the State Street Bridge.
Yeah.
If you put a large flood wall in on the east side, part of the creek, you're gonna take out over also.
Yes, and we'll talk about that. Absolutely.
Hey, Heather, there was one question online. And this is one
Okay.
I forgot. It was from a little earlier and the question was just asked, and I know the answer, but I think it would be good for you to tell everybody. Someone asked whether or not, section 106, whether or not there was a section 106 analysis as part of this process, the historic preservation process.
So section 106 is required, it's required compliance with the National Historic Preservation Act. And what it does is it makes sure that we are not adversely affecting any property, structure, historic district, things like that, that could be or are listed in the National Register of Historic Places. It also includes looking at potential archaeological sites. So a phase 1 report, which is the first part of the report, was done for the areas that we're planning on impacting or that could possibly be impacted. The second part of it, we are still walking through. We are walking through consultation with one of the tribes, I believe, and we are still trying to work with, so let me go back. So down here in Water Street, where we're looking at doing potentially a flood wall or a levee, FEMA did the buyout several years ago, right? So FEMA at that point was supposed to have done the cultural resources in the section 106 compliance with this area. Did you know that FEMA's now in North Carolina and Tennessee and things like that for Helene? And while I've been working back and forth with FEMA and PEMA to get this information, all of a sudden, right before the meeting, they had to go take care of that. So we are going through the section 106 process. Yeah. It is certainly not complete. We are, like I said, we are in the process. We've shared information with SHPO, but we have not completely cleared all the cultural resources parts of this project yet, but we are walking through the process. Oh, does that answer the question, or does that just stir up more questions?
That answered it on our end.
Okay, very good. Sure.
So going forward for the rest of the meeting, we have to kind of keep in mind, like, the order moving forward, we're gonna have to give up a little bit as a borough, protect the borough. It's not gonna be a situation where we'll be able to have our cake and eat it too per se. We might have to move the footbridge, get rid of footbridge, flood walls, you might come down the road and like, oh, I don't like looking at that. But at the same time, Main Street's not gonna flood. People are gonna be able to move in and have businesses. They're gonna be able to get affordable flood insurance. There's a lot of different things that go into it. And it's up to us as a community to decide on this. But at the same time, like I said, everybody's gonna have to give up a little bit to get a lot. So let's keep that in mind.
And we will talk about a bunch of what you just brought up. So, because part of this meeting is to fully disclose the good, the bad, and the ugly of what we're looking at and what we're proposing. And then to have you inform your community leaders as to what you like, what you don't like, and if you don't like something, if you have a way to improve it, we're happy to take that too, for them to make the decisions as to what they'd like to move forward with. So we had a question about what these levees and flood walls could look like. I'm gonna turn it back over to Mike to tell you more.
Thank you, Heather. Okay, so we had a question earlier about what do we do with the water on the upslope side of the wall? So these next couple of details will hopefully help to clarify that. So the wall again would look like something like this, where you have a reinforced concrete element, and then have some type of architectural facing on each side. So just for some rough visuals, something like this might be the ballpark of what we're looking at. In this detail, the creek side would be over here. So on the upslope side, we would have some type of a riprap line swale to help collect water that accumulates on the upstream side. Now, during day-to-day storm events where the creek isn't flooded, but it's raining, the rainwater would be allowed to exit through some type of an outlet pipe or catch basin. But during a flooding situation, you might install something like this flap gate on the end of these pipes to close them off from the creek water. And then you would need to activate a sump pump with a pipe that went up and over the wall to keep the upslope side dewatered. Yeah, well, probably electric. So that we were going to touch on that later. You'd have to run electric to the pumps. And the goal would be to limit those to the minimum number needed, but that's kind of a critical feature with a flood wall. So we mentioned access points. So we had something in mind that would be like concrete stairs at some critical locations. So on the left detail here, we kind of show the flood wall, and then you would basically have a set of stairs on each side with some type of a landing on top so you could get up and over. And then we have just some rough visuals there. Yes,
We
yeah,
include that visual.
yeah, or a ramp. And then again, just some visuals if a levee were to be implemented at the southern end of town. Don't take these dimensions to heart, but this is just kind of a typical configuration of a levee. It would be an earthen embankment, typically vegetated. For some instances, you might use riprap to stabilize the bank and the flow area. But it might look something like this. So going through this flood wall system, we did some rough construction cost estimating for the 10-year storm option and the 25-year storm option, using typical construction cost data. And kind of the way we evaluate the economics is we look at the total construction costs for the project. We determine approximate annual project benefits, and those are determined through a detailed hydraulic model that assigns damage values to different structures based on different types of flooding. So we can determine for a given storm how much damages would occur approximately. And we tried to calibrate that model to the damage assessments that we got from all of you folks during the last public meeting. And so we determine an annual project benefit. We convert the total construction cost to an annual project cost based on the total design life. So think of like a house mortgage. That's kind of the annual cost of the project. So looking at the economics, we compare what is the benefit versus the cost. And obviously we would like the benefit to be greater than the cost. In this case, they're roughly approximate. which maybe Heather will talk on more, but from the NRCS perspective and evaluating a project, if we're getting pretty close to one, it can be a viable project because there are other things to consider just besides just economics. So again, we looked at the 25-year storm as well. In this case, the 10-year storm has a better benefit to cost ratio. So we think the economics for the 10-year storm are a bit better. And as we touched on earlier, the wall heights for the 10-year storm alternative, we think are more practical. So for that reason, the 10-year storm seems to be looking better at this point. Just to give you a feel for the approximate timeline, Heather had talked about, we're in the planning phase now. Beyond that, there would be a design phase and then a construction phase. So for the planning phase, we still have about 9 months remaining. Crockpot. What we have to finish up is to incorporate any input that we get here tonight or in subsequent conversations with anybody. Then we need to draft documentation. And we have local NRCS representatives working with us for the project now, but to get funding, it needs to go through a review process with the federal branches of NRCS, besides just the state representatives. So there's still a review process to go through within the NRCS. Once we got through the planning phase, we move on to the design phase. We estimate roughly 2 to 3 years for the design phase. What we would do during that time is get more detailed site surveys of the town with a focus on the corridors where the flood walls may be situated. We would do subsurface explorations. So that would be explorations with a drill rig or test pits with a backhoe. And that would be to characterize the soil and rock conditions to design the foundations for these structures. And then there would be permitting with the local agencies for environmental protection, as well as any historic or archaeological features, things like that. And then a more detailed engineering design. So in the planning phase, we do enough engineering to evaluate the viability of projects, estimate heights of walls and things. The more detailed engineering would be to specifically determine those wall configurations. As Heather mentioned, we would have to work around a few select structures, so some specialty engineering would be needed there, and so on. And then the construction phase, we estimate roughly 2 years. That would start with a bidding phase, where we would have design documents available for contractors to review. They would bid on it. There would be a selection process. Once a contractor is selected, they would mobilize to the site, work through the heavy construction, and then eventually get site stabilization. Any questions on that stuff before I hand it over to Andy? Great. Andy's going to take you through what some of the construction might look like.
Well, like Mike mentioned, we're probably on a multi-year timeline to get to the construction point, but I just want to give you some of the highlights of what you might expect if and when we get to that point. It's kind of a multi-step process, very similar to other construction projects that happen around town on a daily basis. So really, we begin with the pre-construction and site prep type of activities. It includes marking all the utilities, establishing right-of-ways, all of that. Before any construction really begins in earnest, we want to make sure that all the erosion control measures are in place. See photos here of installation of the coir log and coffer dam so that we can work in the dry. There are plenty of other erosion control measures as well, like silt fence, stabilized construction entrances, all different sorts of strategies that'll help keep sediment from Martin's Creek. Actual installation of the wall will begin with either that concrete footing that Mike showed on the previous detail, or installing our deep steel sheet pile wall, which would be used as a cutoff for groundwater flow migration and just overall slope stabilization. Not sure if you've seen that before, but a sheet pile wall is usually installed using a hammer, pounding the steel right into the ground, vibratory head, just shaking it right directly into the soil. Here you see a photo of the concrete foundation. Again, that's just used for stability of the wall. The actual vertical component is connected to the foundation to prevent overturning from the forces of the floodwaters against it. This was the photo that's already been shared as far as the finished product. We have the facade that's fixed up with decorative stone, landscaping. We do expect that we will have some other plantings that are positioned near the wall as well, as far as screening is concerned. So we do try to, make these as attractive as we can. Okay, that was real quick, but I'm going to pass it back over to Heather. That's going to talk about the preferred alternative.
One thing I neglected to, before I get into all this, I did want to talk a little bit about, and we talked about this back at the first public meeting. And so if you weren't there, you wouldn't know it, but so much a little bit about the stages with the planning, the design, and the construction of it. I do want to point out that for what we are doing, NRCS is providing 100% of the funds for the planning stage. We will be providing 100% of the funding for the design phase minus permits. And we can also provide 100% of the funds for the construction phase minus the land rights. So the land rights are always a sponsor's responsibility, but we are providing 100% of the funds for construction. So when you saw those totals earlier, that's what NRCS would be providing if this project would move forward. Of course, adjusted for inflation down the road, because it's not going to stay at those costs. But so NRCS is recommending that we move forward with the 10-year storm and controlling the 10-year storm. I'm going to give you some general comments, and I'm going to talk about some good things about it and some bad things about it, and just laying all our cards on the table and saying, what do you think? So we are looking at controlling storms 3.7 inches in 24-hour period and less. We are looking at controlling the nuisance storms. You get 3.8 inches in. So I just want to be very clear that we are only controlling the nuisance storms. We are not insurance requirements or rates, because we're limiting the size of the walls. If we hear from the community that we can make those walls higher, and you do want that protection to the 100-year storm, which could affect or decrease those flood insurance requirements or rates by getting people out of the 100-year floodplain, we need to hear it. We heard at the last public meeting that having walls that were too high wasn't something that was desirable. So that's why we're settling where we're settling and not going to adjust or affect flood insurance. The other thing too is that because we're working at controlling the flooding, we probably will not have controls, any kind of controls for groundwater. Now we can put those sheet piles in to cut off water moving back from the creek, but it may also have the effect that it's going to keep water moving from the uphill side down into the creek. So we are looking at doing drainage features to try and capture some of that, but we may not control the ground that may be causing some folks flooding, as well as if without doing the flood, not as well as if we wouldn't do the flood walls. But I did want to point out that we are not affecting groundwater or flood insurance. Okay, big things. Correct.
Just a note on the groundwater too. That's something that we could better evaluate during the design phase if we do a subsurface exploration to characterize the soil and rock conditions. For the planning level phase, we don't have a lot of that information, but after that exploration phase, we may be able to better assess how groundwater may or may not be controlled.
So the good things about this alternative is that we are controlling those nuisance storms. We're reducing those flood damages by $308,000 per year. And we're reducing that potential for evacuations during the 2-year up to the 3.7 inch. I'm sorry, the 2 inch up to the 3.7 inch rainfall event. So we are hitting those targets. The other things to point out is that we are not planning to impact any buildings. We're not planning on impacting State Street Bridge. We are able to walk to work around those for this. And we are still keeping Martins Creek accessible, mostly viewable. We're providing those access points, and it may work well or be for walking trail plans. The green trails and pathways and things could be done along levees that would still be able to let you get into Martins Creek. We're talking about having fishing access or access up in this area, and then be up here at somewhere in that area to allow access up there. So those are the good things. That and relative's a key word, because I said we are in the creek in some spots, but relatively little environmental impacts. That's the good. The bad. Okay. The pedestrian bridge to make this work is going to need to be removed. It can be replaced. That wasn't factored in, but that doesn't mean it can't happen. Just as a heads up, letting everyone know. There are some large trees along the creek that will need to be removed to be able to get a flood wall in. In Martins Creek to get some of those flood walls. Most of the work will be able, for the flood walls that are done on top of the bank, we'll be able to work on top of the bank. You got to do the work in the creek. And then the other thing too is there will be land use restrictions and easements will be needed from the local property owners. If you live along the creek where the flood wall is planned, the borough is going to be coming to you and saying, hey, we want to put a flood wall right through here. Will you let us do it? And that also means that, remember, we're putting a concrete wall in there, right? That there's going to probably be potential for, like, you probably don't want to put a big oak tree, plant a tree that's going to get 40 feet tall with a 40 feet roof wall right next to a flood wall. Right? You might be okay, but whoever buys your house after you may not. So the easements may be fairly large so that the borough has the ability to come in and maintain that. And if they see someone put an oak tree in right next to the wall, they can do something about it. It's something that you need to be aware of, because it means that you no longer have full control over what happens on your property. The other thing too is you're going to have temporary construction impacts. There's no ways around it. It could be noisy. You're going to have random construction folks walking all over your, hopefully in your corridor, but still on your property. You're going to have heavy equipment on your property. They're going to be making noise. You'll have exhaust a little bit, but normal things associated with construction work. Short term, yes, but it's going to happen. So we need to make sure that you're aware. So those are the things, those are the cons that we see to this. And maybe you could say the con is it doesn't affect flood insurance. It kind of just depends on your perspective and what your goals are for this. Bad and the ugly. Oh, we walked through how we got to this point, to the point of making decisions. This is where we're very interested in hearing, and if you don't want to talk to us, talk to these guys, please, because they're the ones that are gonna be making the decision. And they're ultimately the ones that are gonna have to say, yeah, we're moving forward with this, we support it, and we'll get the land rights to do it. And then once that's done, we will finish everything up. And then ask for those funds that we need to move forward with design and construction so that we can finally implement that plan. So with that, that's what we have for you tonight. We do have some up front here. If you want to take a closer look, sometimes it's easier to see on paper than it is up on the screen. Some of the different things we looked at, like the trolley corridor or wide, or where the flood walls might be located for the different storm events, as well as it might be easier to pick out on these maps your property. You're welcome to come up and look at those. We're also happy to talk, and Mike did say that he has the models along, that if you want to say, well, hey, how deep would the flooding be in at my house during this event? He would be the one to be able to show you that. So with that, I'm going to open it up for discussion, questions, comments, whatever you guys want to throw at us.
Take it off my, county thing down there, my Nicholson Borough. Take on it. In 2004, I was local coordinator for Nicholson Borough, and 2006. In all the work we did, we found a project very similar to this that was approved and ready to go back in the late 60s, early 70s, if I remember correctly. And residents that were going to, their properties were going to be affected, shot it down. They said, no, you can't put a wall in my backyard. That's why there's no wall. So just so everyone understands, you know, we've been through this process, and the residents, the same people who flooded in 04 and 06, some of those very same people were the people who said, no, you're not going to put a wall. So just keep that in the back of your head as you look at this and say, does having a wall in my backyard, is me being able to look at the stream more important than having a 5-foot wall?
I'm happy with a 12-foot wall.
Again, just wanting to point that out. So, this very similar project was approved, and no, because they got a bunch of feedback, a bunch of kickback back then from the residents that didn't want that in my backyard. So,
Do you have a feeling on what everyone's opinion is right now?
Right now, everybody's in the room, I think it's affected, right? Well, I think we're missing too many people that are involved now.
But I feel as though the people that reflect upon what you have just said did not receive the damage that some of the kids words.
Right.
It doesn't get worse than we're used to get. I was hoping for this wall.
and I understand these, but
I will, I'm care about looking at the wall. Go ahead.
and again, just to bring that point up, because
And to
it
your,
only takes one or two property owners to kibosh this whole thing.
and to your point, that's what we had heard when we started this, that at that point, flood walls were proposed, but they were to address the 100-year storm, and they were significantly higher than what the community had a taste for. So that's the main reason that we backed off and are looking at smaller events. If the community says, yeah, we're willing to have a 12-foot wall in our backyard or a 7-foot wall, we can go back and revisit that. We're happy to do it, but we need the community support to say, yes, that's worth doing. And are you willing to have that versus a lower wall that's at least going to control that nuisance flooding and take some of the edge off? It's not going to, the 2004, the 2006, we're not addressing that flood. You guys are still getting flooded on that kind of storm event. This is more than nuisance to lower level flooding and taking that edge off.
fault, everybody knows, you're just getting, you're out of control. Me. 3-foot wall, and as you said, it controlled the news. But we're gonna get some nasty rains again, they're not bombing.
Well, you guys all want it, we could have a meeting kind of community, just going out the table saying on the 11th, and we can sit down as a town. Well, how about the 12th? Well, Tuesday, the 12th is Veterans Day. Yeah. We'll do Tuesday, the 12th, and then, you know, as a community, we can talk about everything that you learned here today, you know, and kind of move forward or whatever you guys think, you know.
So the flow of the water in the flood. I live. Methodist church, it comes right around there. Levee in back of my house is broken in spots. And will the water flow in my property more? Because my backyard gets flooded up to my house.
Can I ask you to look at that with Mike after
Okay.
and look at the models, because I have a pretty good idea where you're at, and I'm not planning on filling in any of the gaps in that broken levee. So I just want to make sure I tell you the right thing. That's why I'd like, if we can look at the model.
So will the flow of water from the flood walls during a storm, that will impact my property more than it has?
That's what I'd like to look at, just to make sure I'm telling you the right thing. Because I'd love to say 100% no. But I want to tell you the right thing.
Because this last storm, my backyard was flooded up to. But it does come right up and it's large.
So are there any questions online?
Nope, no questions.
I just like to thank you, like, a clear amount of thought and effort in bringing work. Yeah, see, it was already called out. I'm sure I know, we probably called it out, but I mean, I hope we can incorporate the walking trail into this. I also like to just put it out there. I think it's probably to look at existing. I'm sure that this is all work together. I think that's really, really important. With this, that we have a meaningful. What needs to happen, when it needs to happen, how it needs to happen. Quotes on salt pumps fail regularly. Stagnant for a long time and maybe rolls around. I don't know what that looks like. It may be contained in a box, whatever. As we move forward, we need to make sure that we really truly understand the maintenance that we're signing up for here. Whose responsibilities. Get to a point where we are closing 92, who's doing? By the fire department would be the most reliable one. I think there's about 4 or 5 of us in here that figure a lot of this is going to fall on this, so just want to make sure.
So let me address that, and I see there are 2 other comments. The maintenance is probably one of the big things that I neglected to have on the ponds. Because it is mechanical, there are mechanical parts to it. And you're right, if you don't have the proper maintenance, you get a bathtub effect of the water coming down and getting caught behind the wall. One thing that we didn't talk about that could potentially be a part of this is some kind of flood warning system to help trigger either the fire department or local maintenance. Okay, but beyond the routine, okay, every so often we have to test the pumps, every so often we have to do this. But okay, there's a storm event coming. Or already received this much water in the watershed. let's start getting ready. What does that look like for each of those different flood depths? So that's something that's in the back of my head that we haven't fully fleshed out, but I could see being an integral part of the project.
Do they have? Is there down the water up here? Okay, all right, good.
It's Charlie.
Yeah,
everybody.
I know.
You say it all night long.
Yeah, somebody had
All right, gotcha. That is available, some of those detecting systems are easily. They're not cheap.
No, and it's figuring out those thresholds
Oh, great.
is more where I'm looking at. Nathan, did you have a question?
No, you answered it.
Okay. And the other gentleman, did you
I
have?
got a question on, the hydrant system in town does not sustain a big water impact. Is there any kind of dry hydrants or access that could be put into this wall of the gain water? Our main water access is Water Street, Nicholson Tire, and downward on Elvis. So if we have a wall in there, we lose our access to get water for a large fire down. Is there any kind of provisions you could put in that wall to get water, like dry hydrant or a pond?
I don't know that we considered that, but I think that's a really good idea.
Yeah, do you need, vehicular access or would just a pump be effective enough?
If we could, a dry hydrant, so a dry hydrant is a hydrant, or it's a piece of pipe alongside the road.
Yeah.
It would go through the wall into,
Or over the wall in a
Or
certain
over the wall.
location
and we just gotta be careful
on the head.
the height of the wall,
Yep.
because you can only have so much lift.
Yep.
Pump it apart. So if there's lower sections in the wall system, that we can incorporate something that we can get water access in the event of a big fire.
So the challenge is those lower wall sections are on a higher bank.
Right.
So you're still gonna have the same, so
Well,
we might have to try and figure out something underneath and
just
through.
concerned, you know, that's our main source of water
Yeah.
for
Yeah.
anything within our.
And we have a standard for dry hydrants. We've done several
That's
designs.
good.
for those. At least ponds and I think a couple of creek accesses too, but. What else?
Long term. So I know I've been on council for a couple of years now. I completely understand why we don't dredge anymore. But see the plan, this has like 50-year lifetime. So as we're not dredging, people that have been in town here a long time know we've done, I hear the story all the time. Bob the buildings, they're on his D9 through the creek, and we never had flooding, right? Yes. So what happens as the sediment continues to build up within the existing bed? And 50 years from now, we've gone from the creek bed being here to now it's here, and now we've just completely negated the wall.
Well, I guess one thing to think about is that is a reality. And I guess the need for future dredging, I guess, wouldn't necessarily affect the project now. That may just be something, regardless of what we do, that might be a reality down the road. One thing I could say is with the flood walls, you get more flow capacity at the higher elevations because by the time we get to the walls, we've really widened out and we've added a lot of flow area at the flood wall section. So that means that the area that's occupied by the sediment accumulation at the bottom affects your capacity less as compared to, something that has more of the flow area down below. But it could be a reality to deal with later.
And wouldn't you also generally be restricting it so the water may be moving through and flushing through a little bit more efficiently?
Yeah.
I'm not saying it won't be, but for another project that I'm working on, we did a sediment study. And I would think that would probably be a part of a design that we would have to do on just knowing the area that we're in. Designing for that. So, and what that means though, is that right now, those wall heights that we're proposing are without any kind of sediment accumulation. So if we are planning now in the future for 1 foot of sediment or something like that, that makes those heights a little bit bigger. So that's just something that we haven't gotten too far in, but we are aware of.
Can the walls be updated in a manner where there can be an addition or extension requirement? If we anticipate, if there's like, hey, the 2 hurricanes, they're gonna be very Nicholson. There a chance where we can be sure like, controlling something. Jersey barriers on them and get another 4 feet, or like, is it pretty much they're constructed and capped and that's it?
Yeah,
Right, so there are structures out there that we use on dam rehabilitations, like fuse gates and things like that, that can temporarily extend up. We were not planning for anything like that for this project. Does that mean it can't be done? No, because the design phase and knowing and hearing that now would be the time, but then you also have to install them between storms. And do you have that time and ability to install them where you need to between storms to be effective?
yeah, I've seen some projects where they think of like steel I-beams as kind of a form, and they have panels that you can lower into place to adjust your height. The drawback is kind of like Heather mentioned, is you have to have equipment and personnel ready to get those in place before the storm occurs. But you know, it's something that could be looked into.
Keep asking questions. We'll get to a yes eventually, I promise. I promise.
So, with, building on his question about the gravel and sediment filled up in the creek panel. Would there any consideration for access for, say, that gravel bar removal? That's gonna be needed. in the future.
So, so another project that I'm working on now was a levee project. And one of the things with that is they did plan ahead and said that you will have to operate, maintain, and remove the gravel from that stream to maintain that capacity through. It was built in the operation and maintenance plan, but for some reason, no one gave them a cross section or the shape of what that was supposed to look like and how deep the stream was put. But that's a totally different subject. So yes, it can be included. The challenge will be the permitting to do it at that time and the cost. Doesn't mean it can't be done, but yes, those access points can be included. Now, on the other side, if you come up and look at some of these plans, then you will see that there are some areas that there aren't flood walls because the bank's high enough that you don't need them. So maybe that's a spot with some creative bank work to allow some of that access. Yep. It can be done, but the dredging itself isn't.
No, I know it's not something that we incorporated into this, but to have that as a consideration, I think is good.
If future dredging wouldn't be part of this project, that would fall on part of.
Correct.
It's like-
And that would be long-term operation and maintenance.
Right.
Would be considered. Someone said about the project life. One thing I do want to point out is that we had to pick a number to run the economics. We're not expecting that these walls are going to fall over in 50 years or that.
Albert Pond fails every storm. It has to fail, yeah.
But
Every storm, just failed.
interestingly enough, Mike has the numbers on how much the water raises if Alfred Pond were to fail completely. And I think it raises the water down by like an inch.
No,
Honestly,
every storm fails, Charlie.
Mike's got the numbers.
You're being told it's failing.
Right.
But every time, Albert Pond just failed.
My point is more that 50-year project life, we're not expecting the walls to fall over. We're not expecting that it's going to go away in 50-year time period. And if you look at Alfred Pond, how old is Alfred Pond? And I'm not, it's not, my point is, it has in 50 years. So maybe that's not a good example to point out. But again, we're looking at, if you do it, we're looking at the long term. We're not expecting it to fall over or be done at the end of 50 years. We just had to pick a point of analysis. Some good 50-year-old, 100-year-old concrete out there. Yeah.
We do like a, recess, so people look at them out and they will talk. Yeah, that's what, it's up to you. Up to these folks.
Hey, we're here. It's all right though, is we're gonna probably shut down the Zoom portion of it since they really can't see the maps too well. Unless you want me to like hold one up. I can like hold one up in front of the camera, but even so, maybe not. But we'll shut down the Zoom portion so that way they can go on with the rest of their evening, and we're happy to stick around as long as people are happy to stick around, talk with us. So again, thank you for your time. And if you're online, thank you again for participating and for all the great questions. Oh, I have one last slide. I'll leave this up a little bit, but this way you have my contact and Mike's contact and Andy's contact. That way, if you would like to follow up with us with any kind of questions or comments, we're happy to take them. And just as a FYI, the recording of this meeting and the handouts and the PowerPoint will be posted on the NRCS website once we get everything processed and we get it all uploaded. So thank you again.
If anybody's leaving in the meantime, on the 12th, 6 o'clock, that works for everybody. Well, that's what we're gonna do. So if you want to be here, be here. If not, I'm voting yes for it.
Don't right overhead for a second.
Okay, Chris.
Thanks, Andy.
You all set then?
Yep, I'll shut it down and we will be done. Thank you so much.
Thank you. Glad it worked out.
Yep.
Take care.